ये सभी क्या किया है आपने?
दोनों ही। यस सर, दोनों का ही देख लो सर, क्योंकि फिर 2 ही दिन बचे हैं, 29 और 1। दो को तो जाना ही है।
स्टार्ट करते हैं, यस। थर्मोडायनेमिक्स स्टार्ट करते हैं। व्हाट द मेन एप्लीकेशन ऑफ थर्मोडायनेमिक्स?
ओके सर।
एक्सप्लेन ब्रीफली।
सर थर्मोडाइनमिक्स, यस सर, thermodynamics is used to study the heat energy, mainly the heat energy. So how the flow of heat takes place, whether the process is thermodynamically feasible or not, such kind of things, sir.
Yes. What's the difference between system and surrounding? Explain. System and surrounding thermodynamics.
So yes, sir. Mhm. So sir, any body which is under our consideration is known as the system, and the remaining part of the universe except that body is surrounding.
System, how many types of system?
Mainly there are 3 types of systems, sir. Open system, closed system, and isolated system. In open system, both mass and energy can exchange. In closed system, only the exchange of energy takes place, and in the isolated system, uh, neither mass nor the energy can transfer.
And what is the difference between homogeneous and heterogeneous system in thermodynamics?
Yes, sir. Homogeneous system is that type of system in which consists of only a single phase, in which there is only a single phase. That is homogeneous system, and if there is a mixture of phases, is known as heterogeneous system.
Yes, good. What are the uses of heterogeneous homogeneous system in thermodynamics? Yeah, chemistry.
Mm, yes, sir. So if if we Mm, if the process under our consideration consists of only a single phase, like if the only phase present is gaseous phase, then that system is homogeneous system, and it will be studied under homogeneous type of systems. But if there is a mixture of phases, like the process contains both gaseous phase and liquid phase, then, like sir, there are many chemical reactions in which gas is evolved, or solid, or a solid reactant is converted into a liquid product. To study that kind of reactions, we look into the heterogeneous type of systems.
Yes, good. What the difference between macro and microscopic properties? What the example? What the uses?
Yes, sir. Mm. So, which are visible, generally visible with our naked eyes, like say bouncing of the ball, vehicles, motion of the vehicles, which we can see with our naked eyes, are generally the macroscopic properties, which we can see or which we can feel with our senses. Microscopic properties are those properties which are not possible to see with our naked eyes, like say the wavelength. mm, Propagation of light, such kind of examples, sir, for microscopic properties.
Yes. Intensive and extensive properties. What the main application and example?
Yes. So extensive properties are those properties which depends on the mass of the substance under consideration, like which depends on the amount of the substance under consideration, like said mass, volume, uh, number of moles. Such kind of properties are known as extensive properties, and intensive properties are those properties which do not depend on the amount of the substance, like sir molar volume, specific area, specific heat. Such kind of examples are of intensive properties.
Yes, good. First is isothermal process. What the main application of isothermal process in thermodynamics? What the uses? Explain
Yes,
briefly.
yes. So isothermal in which temperature remains constant, or those processes for which dT is equal to 0. And in the isothermal processes, the change in the internal energy would be equal to 0. So all the work that is done will be, we can say that all the work that was done on the system is used to transfer heat. So in the isothermal processes, maximum transfer of heat takes place.
Yes. Any example of isothermal process?
Any particular example, sir? Mm, right now, I cannot recall any specific example, sir. But if we consider Carnot cycle, which consists of 4 curves, so the first and third curves of that Carnot cycle are types of isothermal processes.
Yes, good. Yes, you talk about Carnot cycle. Yes, what the interrelation of isothermal process and Carnot cycle? What the main application of Carnot cycle?
Sir, yes, sir. So Carnot cycle is we can say that Carnot cycle is a perfect cycle which is used to study the efficiency of the is a perfect engine. If we is the engine that we have formed, we use Carnot cycle, sir. So its efficiency of the man-made engine or the efficiency of the irreversible engine is compared with the Carnot engine. We can say that, sir, Carnot engine is a perfect engine uh, whose efficiency is maximum. And apart from this, sir, we can say that the Carnot cycle can isothermal expansion, then adiabatic expansion, then isothermal compression, and then adiabatic compression. So this it will form a complete cyclic process.
Yes, good. Any drawback of the isothermal process in thermodynamics?
Any drawback of isothermal process, sir? I think, sir, in actual practice, it is very difficult. In actual practice, the isothermal process are very difficult to form. So, I think, sir, there isn't any process which is completely isothermal.
Yes. Yeah, next, move on adiabatic process.
Yes, sir.
Isobaric,
Adiab-
isochoric, cyclic process. Yeah, what is the difference of these one?
Yes, sir. Adiabatic processes are those processes in which the heat exchange is zero. Isobaric processes the pressure is constant, and in isochoric processes the volume change is zero. So if we talk about the reversible work, maximum work is done in isobaric process, then in isothermal process, then in adiabatic process, and the least amount of work is done in isochoric processes.
Any example of these process in thermodynamics?
An example of these processes. Mm, Sir, isothermal and adiabatic processes are, we can see these two processes in Carnot cycle. In isochoric, example of isobaric process, if we keep the temperature constant, in that process will be isobaric process, and if we keep the volume constant, then that process will be isochoric process.
Yes, what the main application of reversible and irreversible process in thermodynamics?
So, all those processes which we see in the natural world, all those processes which are non-spontaneous are irreversible processes. The reversible processes are, we can say that ideal processes which are not possible in the natural environment. So reversible processes are studied just to compare their efficiency with the non-reversible processes.
Yes. Any example of reversible, irreversible process in thermodynamics?
Reversible processes. Mm, uh, at this moment, I cannot recall any specific example, sir. Reversible process, we can say Carnot engine. Carnot engine is a cyclic
Yes.
reversible process. Equilibrium reactions are also reversible in nature.
Yes, good. Next, move on work. What the difference between work done on the system, work done by the system? Explain.
Yes, sir. So if external work is done on the system, we can say that, for example, if we increase the pressure and compression will take place, or the work is done externally, that will be known as external work, and we take external work as positive work. If work is done by the system, like the expansion of the system, then such type of work is work done by the system, and a negative sign is used to represent the work done by the system.
What the difference between electrical work and non-pressure volume work? What the difference?
Sir, non-PV work is, we can say that the non-PV work is the gives free energy. Non-PV work is gives free energy which we can extract from a system.
Yes. Good. Next is function. Yes. What the difference between state and path function?
So, sir, if process depends on the path followed, then that will be known as path function. And if it doesn't depend on the path followed but depends on the initial and final state only, then that will be a state function. So examples of, for example, path function is work and heat, and energy and energy like internal energy and enthalpy, entropy. All these are examples of state function.
What the main purpose of state function and path function in thermodynamics? Main purpose.
Main purpose. Hmm. Sir, just give me a second to think. Hmm. Sir, I think, sir, if we need to study the transfer of energy, then that can only be studied under path function. How the energy is transferred from one point to another point, then that can be studied under path function. Mm. And if we focus only on the initial and final state, then that will be studied under state function.
Path function is Q and W. Yes, no.
Yes, sir. Yes.
What are the uses of these one in thermodynamics? How many uses?
But are uses of work done and heat, Q.
Q and W.
Yes, sir. So one use is that, sir, if we need to induce specific rotations or specific kind of motions in the surrounding, then work we or specific kinds of motion are generated in the surrounding, then work is used, or to generate specific kind of motions work is used, and to generate the random motions heat is used. Or this can also be used to differentiate between work and heat, sir. If random motions are generated, then that will be heat, and if specific motions are generated, then that will be work.
Yes, good. Next, move on zero law of thermodynamics. What the main application
Yes,
of zero law of thermodynamics in thermodynamics?
sir. Yes, sir. So zeroth law of thermodynamics states that if A is in equilibrium with B, and B is in thermal equilibrium with C, then A and C are also is in thermal equilibrium with each other. This is the zeroth law of thermodynamics, sir.
What's the difference between zero law of thermodynamics and zero order of reaction?
Zero order of thermodynamics and zero order of reaction. So zero for order of reaction is that kind of reaction which doesn't depend on the any reactant. We cannot change its rate. And so zeroth order of zeroth law of thermodynamics deal with thermal equilibrium only. It doesn't deal with any other kind of equilibrium.
What's the difference between order of reaction and law of thermodynamics?
Hmm. Sir, thermodynamics thermal part, or the we can say that it doesn't deal with the rate part only. It doesn't deal with the rate part. A process can be thermodynamically feasible but kinetically unfeasible. So order of reaction deals with the rate of the reaction, or deals with the kinetic part, and the laws of thermodynamics deals only with the thermal part, whether the process is thermodynamically feasible or not.
Yeah, next move on first law of thermodynamics. What the main application of first law of thermodynamics in thermodynamics? Explain briefly.
Yes, sir. Sir, first law of thermodynamics states that energy can never be created, nor can it be destroyed, but can be converted from one form to another form. So this is the main definition of the first law of thermodynamics. And mathematically, we can represent first law of thermodynamics as du is equal to du, or change in internal energy, is equal to dq plus w.
Daily is equal to Q plus W. Is explain what the uses of these term in first law of thermodynamics.
Sir, W represents the change in the internal energy. The exact value of internal energy cannot be determined. So first law of thermodynamics is used to determine the change in the internal energy of the system. So del Q is the change in the heat transfer. What amount of heat that is supplied to the system, or if any heat is extracted from the system, that will be represented by del Q. And W is the work done, sir. If work is done on the system, then W will be positive, and if work is done by the system, then W will be negative.
Yes, what the relation between isobaric process and first law of thermodynamics?
Isobaric process and first law of thermodynamics. So first law of thermodynamics is, sir, du is equal to del Q plus W minus K PdV. So if the process is isobaric, then du will be equal to dq minus PdV, sir. So we can say that if the process is yes, sir. This will be, I think this will be the relation, sir.
Yes. L cube minus PdV. Yes. Here is what is heat? Yes, Q. What is heat?
Heat. What is heat? So heat is a specific. Heat is a form of energy which is used to change the temperature of the system.
Yes. What is heat capacity?
Heat capacity required to raise the, if the amount of substance is 1 gram, that it then it will be specific heat capacity, and if the substance is 1 mole, then it will be molar heat capacity.
Yes, good. Next, move on. Second law of thermodynamics. What is second law of thermodynamics?
Yes, sir.
The main application of second law of thermodynamics.
Yes, sir. So the second law of thermodynamics confirms us that it is impossible to construct a machine which works in the cyclic process and which can bring which can transfer which can transfer heat from a cooler body to a higher to a cooler body to a from a cooler body to a hotter body without any external work. So this is the second law of thermodynamics, sir. Or also we can say that, sir, it is impossible to construct a machine which works in cyclic process, which can generate only which can perform work only with heat. So it second law of thermodynamics confirms that it is not possible to convert all the heat provided to the system completely to work. There will be some other effects also.
What is entropy?
Yes, sir. So entropy is the randomness. We can say entropy is the measure of randomness of a system. How much random is the system or is the substance is its entropy. The higher will be the entropy, the more are the chances that the process is feasible, sir, or more the process is spontaneous.
Yes. What the difference between entropy, absolute entropy, residual entropy? What the difference of each one in thermodynamics?
Residual entropy and
Entropy, residual entropy, and absolute entropy.
so entropy at any particular temperature is entropy of the system if we can if according if substance is purely crystalline, then its entropy at 0 degree Kelvin will be 0. But if the substance is not pure, then its entropy at 0 degree Kelvin will not be equal to 0, and it have some particular value, and that particular amount of entropy is known as residual entropy. That is, sir, entropy at 0 degree Kelvin, at 0 Kelvin of a impure substance, or the substance which is not perfectly crystalline, that entropy is residual entropy.
Yes, good. What the difference between spontaneous and non-spontaneous system in thermodynamics?
Yes. Yes, sir. So all the processes which are possible are non-spontaneous processes, and all the processes which are ideal, we can say that are spontaneous processes. According to thermodynamics, if value of delta G is less than 0, then that process will be non-spontaneous, and if the value of delta G is greater than 0, then that process will be spontaneous process. Spontaneity, we can say that, sir, spontaneity determines the feasibility of the reaction.
Yes. What is Newton's law?
Sir, so that law states that if a substance is non-associated, that is, in its present form or in its gaseous forms, there will be no H bonding in them, and the boiling point of that particular substance is higher than 150 180 150 Kelvin. Is if boiling point is higher than 150 Kelvin, then the entropy of that particular substance is fixed, and that fixed entropy is equal to 10.5 R kilo 10.5 R, yes, or which is mathematically roughly equal to 88 joule per Kelvin per mole.
What the difference between entropy and entropy of mixing? What the difference?
Substance, but if we take a combination of these substances, for example, if we take two gases or three gases, then their combined entropy, or then their combined entropy will be the entropy of mixing. So for example, if we take N2 and H2, both gases have their particular entropy, but if we mix these two gases, then the combined entropy will be known as the entropy of mixing. And so there is a direct formula for calculating entropy of mixing, which is states that entropy of mixing is equal to R summation Ni ln xi in joule per Kelvin or R summation xi ln xi joule per Kelvin in joule per Kelvin per mole. I is that particular component which is under our consideration. This is the entropy of mixing, sir.
Yes. Next, move on third law of thermodynamics. What is third law of thermodynamics?
Yes, sir. Third law of thermodynamics states that for the pure crystalline substance, the entropy at 0 Kelvin will be equal to 0.
Yes. What are the uses of third law of thermodynamics?
Uses of third law of thermodynamics. Sir, I'm not very sure, but I think third law of thermodynamics can be used to define the absolute scale of temperature, or it can be used to find out the absolute zero. Like, sir, if we take a pure substance and if somehow we make its entropy equal to 0, then that particular temperature will be 0 Kelvin or absolute 0. So this can be one application of third law of thermodynamics, but I'm not very sure, sir.
Any example of third law of thermodynamics? Uses of example.
I think real examples of third law of thermodynamics are cannot be possible, sir, because it is impossible to reach at absolute zero. Absolute zero, absolute zero is only a theoretical concept, sir. Practically, it is impossible to reach at absolute zero temperature.
Yes, any limitation of third law of thermodynamics? 0, first, second, third.
Yes, sir. This for third law of thermodynamics, this is the major limitation, sir. That we cannot reach at absolute zero temperature. And sir, for the limitation of first law of thermodynamics is that, sir, it doesn't give any information about the spontaneity of the process, and it also fails to explain the direction of the heat. First law of thermodynamics, sir. And for second law of thermodynamics, one limitation of second law of thermodynamics is that, sir, it is applicable only to closed system.